Okay, everyone, I'm just going to go over a few things to help you with the problem set that's due Monday. Just a couple questions we've had about some of the binary nature of things and some of the constraints, as well as the fire station problems, just to help everyone all at once with some of the questions that we've been seeing. So you see here, I've got part of the setup for the humanitarian shipping question. We've got just the given cells in yellow here. And then I created an orange column for whether or not to take the item, 0 for no, 1 for yes to take the item. You can see you set that up with a binary constraint. I just filled them all in with ones randomly to demonstrate some of the things you can do with the power of these binaries. So one would be as if you were told that you could have A or B, but not both. What you can do for that is you can, in your blue cell, in your constraint, you can add A and B together. And since they're just going to be ones or zeros, you've got 3 possible combinations. You've got 0 if you take neither of them. You have 1 if you take one of them but not the other, or 2 if you take both. So what I did is I added them in this cell right here, and then had a constraint where they had to be less than or equal to 1. So that means I could take A, or I could take B, or I could take neither A nor B, but not A and B, because if that's 2, then it won't work. And since this is an insolver, these are just going to be whatever what's plugged in given this solution that I put in here. But in solver, you would put this in as a constraint, where this cell has to be less than or equal to this cell, and then it would make sure not to do it. Here's another one where you could have it with possible 3 options, where you could have D, E, and F. You need to have at least 2 of them. So you could have D and E, or D and F, or E and F, or D, E, and F, but you couldn't just have D, or just E, or just F. And so for this one, similar, you add together the 3 orange cells for those. Again, with 1 being yes, taking it, and 0 being no, take it. Add them together in this cell, and have that having to be greater than or equal to 2, where we have at least 2 of those. Again, put that into solver. Lastly, I have one where of 4 options, you need to have exactly 2 of them. And so here we would add up I, J, K, and L, these 4, which I do in this blue cell, and then set that with an equal constraint to 2, because that's what it asks for. So that's the easy way to do it. It's a lot better than trying to do if statements and that sort of thing that can get complicated and can gum up solver. So you can do lots of cool things with binaries because it's just ones and zeros. You know what's going to happen if you add or subtract or multiply. That's basically how we do the fire station question as well. Oh, and just another note, this isn't the complete model for that one. It's just part of it set up to demonstrate these. And these aren't the actual questions from the problem set. We also use the power of these binaries in doing the fire station problem. This isn't the same fire station problem that you guys have. It's a little bit different, but I just set it up to show some of the principles. So again, you do binary with these purple cells, and you do binary with these orange cells. Now with the orange cells, you'll set a binary constraint when you're in solver, and I just put some in here. And what you would do with these purple cells is see whether or not, if there's a fire station in this tract, if this house is being met. So 1 if it's yes met, a 0 if it's not. For this example, it has to be within 8 minutes. So in the purple cell, we have a formula where it's if this cell is less than this cell, then I'll put a 1 for yes, it's being met, comma, if not, which is the value false right here, a 0, meaning it's not met. So do that same thing for all of these. And so how I would interpret this is if there is a fire station in tract 1, it is within 8 minutes of houses in tract 1 and houses within tract 2. Here for fire station 2, the only tract that's within the required 8 minutes of this problem is houses in tract 2. If I'm looking at it from this direction, from the house direction, what I'm saying is house 1 is within 8 minutes of which possible fire stations? It's only fire station 1. Houses in tract 2 are within 8 minutes of which fire stations? It's only going to be if there were a fire station in 1, 2, or 3. And so I'll set that up that way. So you can see that it matters which way you're going. It matters how you're going to interpret this. We want to do it from the house perspective because we're assuming that we haven't built fire stations in all of them. If we go in this direction, we're seeing basically if these fire stations are within 8 minutes of any location, and they all are. You also see up in here that these aren't the same necessarily in each, and even a fire station in tract 1 and a house in tract 1, there's actually a time difference. This is possible because you could have a fire station on one end of the tract that's far enough away from where the houses are in that tract that there's actually a time difference between them. And then same thing between different ones, where from the fire station in 2 to 1 versus the fire station in 1 to 2, because the houses and the fire stations could actually be in different locations, the response time can be different. And you'll find that I think that happens in the example for the problem set a little bit as well. So back to solving this, we'll set up our tracks there with the binary, as I said. Our green cell is going to be a sum product of the costs of building the different stations and whether or not we build them. And then our blue cell constraints are going to be sum products of this and this. So this, basically what it's doing, it's multiplying whether or not tract 1 is going to be met. So it's taking by where stations need to be for it to be met times whether or not there is a fire station built there. So the way the model is right now, with 1 being built in 1, we have 1 times 1 there, and we have 0 times 0, 0 times 0, 0 times 1, 1 times 0, 0 times 1, 0 times 0, 0 times 0. So the sum of all of those products or multiplications is going to be 1 because we have this one times this one. That 1 means that a house in tract 1 is being met within 8 minutes by one of the fire stations that we're building right now, the one there and 1. And then we go with 2, same sort of thing with its blue cell. Again, we do the sum product. We have 1 times 1, 0 times 1, 1 times 0, etc., where we end up having a sum of 1 where it's just this one and this one. Again, with 3, we're going to do the same thing. And this time we'll see that we do have it being met by having built one in tract 6, etc. down the line. And you'll see that with these 4 fire stations in this example, we have all of them met. So all of them are being serviced within the 8 minutes that's required in this question. So it's important to be able to go through and interpret this after you have it done, because if you have it going the other way, it wouldn't make sense. It's also important as you're setting this up to keep in mind which direction to set up your orange cells. That makes the most sense so that you can get the sum product to work, because the sum product won't work if you have a range going this way and then a range going the other way. That would need to be an M-mult, which is a little more complicated of a formula. And so you can see in this way we have that all set up. And again, we want them greater than or equal to 1, meaning that at least 1 fire station reaches them. It could be 2. Your boost could be 2 if it was being met by a second, like if we ended up building 1 in place 2 as well. In tract 2, then you'll see that a house in tract 2 is now being serviced by fire station in tract 1 and in tract 2. But this is not necessarily the optimal solution because then it increases our total cost, as you see there. And then if we get rid of that one, we see the cost drops down. So hopefully those are useful things for you guys to think about. If you would like more information on that or you have more questions, please email Leela, Kulani, or I, and we can help you out. So thanks. Hopefully that's useful, and good luck finishing the problem set.